Hello everyone. In this video we're going to be solving a quartic equation, a polynomial equation with degree 4. We have x to the fourth power plus 7x minus 12 equals 0, and we're going to be looking for x values, real and complex, all of them. Great. So, there's a quartic formula which kind of depends on solving the cubic, and the cubics can be solved by using Cardano's formula, Tartaglia's formula, Ferrero, a lot of guys who worked on this, but anyways, but those formulas are complicated, and this problem is kind of special because we're missing a lot of terms. We don't have the x cubed, we don't have the x squared. So we're going to try to factor this polynomial using integer coefficients. Okay, so let's go ahead and write this as a product of two quadratic polynomials. And this is what it's going to look like. So you can go ahead and write it like set it equal to x squared plus ax plus b multiplied by x squared plus cx plus d. But one thing to keep in mind is we don't have x cubed. And if you think about how you can get x cubed from here, the only way to do that is either you multiply x squared by x or x by x squared. We don't have a lot of choices. So in order for them to cancel out, for example, in this case, you're going to get cx cubed and ax cubed, and you want that to be 0x cubed. So that means a plus c is equal to 0, or a and c are opposites. So instead of going through lots of loops here, we can go ahead and do the following. We can just go ahead and write our expression in such a way that a and c will always cancel out, or c doesn't even exist. So here's what it looks like. We're going to write x squared plus ax plus b as our first factor, and the second factor, instead of using cx, I'm going to use minus ax, and then I can use a c now for the constant, or if you don't like that, you can use a d. Okay, doesn't matter, no big deal. This is fine. Now, when you multiply, when you distribute the x squared over the negative ax, you get a negative ax cubed, and then you get a positive ax cubed, so the x cubed cancels out. So this is good because it eliminates the number of variables we have to use. Therefore, solving this as a system will be easier. Okay, so we did this so that x cubed can cancel out. Awesome. Having said that, let's go ahead and distribute this. So we're going to get, and I want to start with the right hand side. So I have x to the fourth power minus ax cubed plus cx squared. I'm distributing, this over everything, and then I'm going to be doing it for all the terms. And then I'm going to focus on ax. Distribute ax cubed minus a squared x squared plus acx. And then I'm going to distribute b plus bx squared minus abx plus bc. Now, how did I know that I'm going to be getting integer coefficients from here? Well, when you start a problem like this, you don't. Sometimes, or most of the time you don't. You just test it out. If this doesn't work, then we're going to have to try something else. So x cubed cancels out, and let's go ahead and arrange the x squared terms together. So we have a cb, and so it's going to be like b plus c, and then I have minus a squared. That is the coefficient of x squared. So I've taken care of this, this, and that to keep track. And then I have acx and minus abx. Let's go ahead and put those two together. And finally, I have the bc. And the whole thing is equal to that. X to the fourth plus 7x minus 12. Okay, we know that it's equal to this, right? Therefore, I can just go ahead and designate or just write down what the coefficients are for. So this is going to be, okay, we don't have any x squared here, so this is going to be 0. The coefficient of x in our expression is 7, and this is going to be negative 12. At this point, you can kind of do guess and check if you want, but I'm actually going to solve this as a system. So it's not completely random. Okay? So I get the following. B plus c equals a squared. And then I get AC minus AB is equal to 7. And I get BC equals negative 12. We have 3 variables and 3 equations, so it's all good. Let's go ahead and manipulate the second one a little bit. Take out A. and then divide by a, so that we can get something for c minus b in the form of a, or in terms of a. Okay, so this is something I'll be using. Now notice that I have b plus c and I have c minus b, right? So we can go ahead and put those together and eliminate. So let's rewrite this as, it doesn't really matter, no big deal, but I guess for convention's sake. So we can write the first one as c plus b equals a squared, and second one as c minus b equals 7 over a. Then add these equations up, b cancels out, and we get 2c. 2c or not 2c? Do you see what I see? Hopefully. And now I'm going to make a common denominator, and from here I'll be solving for c. So if you divide both sides by 2 or multiply by 1/2, c becomes a cubed plus 7 over 2a. Awesome. So I got c in terms of a, and I would like to find b in terms of a as well, but that's kind of easy because we know that c plus b is a squared. So in other words, b is a squared minus c, right? So I can write the b as a squared minus a cubed plus 7 over 2a, and distributing, you get 2a cubed minus a cubed minus 7 over 2a. So for b, you get kind of like a conjugate looking term, right? These two are conjugates. Well, whatever, they are. Okay, great. Now, how do we put these two together? We have a third equation, remember? We have bc equals negative 12. So now we're going to use that here. bc is equal to what? A cubed minus 7 over 2a times a cubed plus 7 over 2a. Because remember, we found c first. Now their product is going to equal, now from difference of two squares, you get a to the 6 minus 49 over 4a squared. And as you know, bc equals negative 12. Awesome. So this is equal to negative 12. I know this kind of looks messy, and 6 power is like, what? Okay, don't worry about it, because we're going to solve this, and it's going to be very easy. Okay, distribute, or what is it called? Cross multiply. Yeah, that's the term. Put everything on the same side. And here, I can do a little substitution here, can I? A squared, let's call that k, just for fun. You can call f as well. And you're going to get k cubed plus, if you bring this guy over here, 48k minus 49 equal to 0. Remember, we've seen this a lot, right? The sum of the coefficients in a polynomial is 0. Yay! That means k equals 1 is a solution. But k is a squared. Therefore, you get two solutions. Well, here you don't really have to worry about it because it's going to give you the same thing. A equals 1 or a equals negative 1. Now let's go ahead and find b and c from here so we can kind of plug it in. If a is 1, let's see. b becomes negative 6 divided by 2. So b becomes negative 3 and c becomes 4. You can just plug it in. It's the plus sign. And when a is negative 1, b becomes 4 and c becomes negative 3. So notice that these numbers kind of switch around. And that means in our expression, you know, a value is going to be the same. Well, it's not going to be the same. Okay, never mind. What am I talking about? When a equals 1, this is the case. So here's the thing. You're going to get the same thing because the values differ, you know. Anyways, I'm kind of confusing myself here too. So let's go ahead and rewrite this expression. Remember, our expression was written as x squared plus ax plus b and x squared minus ax plus c. So I'm going to go ahead and plug these in. Let's use the first one. You're going to get x squared plus x minus 3 and x squared. This should be an x, not ac. It should be ax. Okay, I shouldn't be rushing. And that's going to be minus x plus 4. If you use the bottom ones, the factors are just going to switch, so you're going to get the same thing. Never mind. So now set it equal to 0 and solve this. Easy, because these are quadratics. And you can just solve each one. The first one, let's start with the first one. From here we get negative b plus minus the square root of b squared, which is 1, minus 4ac plus 12. And that's going to give you the following. Negative 1 plus minus root 13 over 2. Awesome. And the other equation, unfortunately, well, should I say fortunately, I know some folks like complex numbers. Because the discriminant is less than 0, you get negative b plus minus the square root of b squared, which is 1, minus for AC, which is minus 16. And that is going to give you negative 15. You can write it as 1 plus minus square root of 15i, which is the number whose square equals negative 1. And then we get all the solutions here. All right? Awesome. And now, here's what happens. If you go ahead and look at a graph of this, you're going to notice something interesting. This is a quartic, but it'll only intersect the x-axis at 2 points, and you can kind of see those values. They're kind of symmetrical. Anyways, there's a minimum point, so on and so forth. But this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.